How you must use the function idea, I will tell you, because many people think that function means it's only for numbers. It's not. Okay. Let me give a very simple example. Suppose there is a 3 by 3 square, right? I want to find how many squares are there in this, right? How many squares I can realize this. One way is I know that this is a 1 by 1 square I can count, then 2 by 2, then 3 by 3 and all. It's okay, nothing wrong. I'm not talking about. Suppose instead of taking a square, I know this square is got, you got this junction points, right? It's actually 4 by 4, from which you realize this 3 by 3. Where? So do you see a 4 by 4 here? 4 by 4 junctions, from which you realized here. So if you take a square, geometric square, it has only one center. Agreed or not? Do you have two centers? It has how many corners? 4 corners. It's a relation. So the square has corner here, corner there, corner here, corner there. So it's a relation. But if I say it's a top left corner, there is only one top left corner. Agreed or not? Only one top left corner. If you are going, if you are going to perceive only this horizontal versus vertical. So there is a top left corner. So if I want to go only 1 unit squares, I can go to this 3 by 3 grids. I can't go here. This fellow cannot be the top left corner. So the first round I will be getting only this, which is 3 by 3. Correct? When I take a 2 by 2, these 2 columns I should take off. Why 2 columns? This fellow cannot be the top left corner of a 2 by 2. Are you able to understand? So then I can go only to, see, you can say this fellow can be the top left corner of the square. Are you able to understand? I am looking like a function. A square has only one top left corner. So I can see this fellow as a top left corner of 1 by 1, as well as a top left corner of 2 by 2. When I go to the 2 by 2, what happens? Which fellows will not become the top left corner? Last 2 columns and the last 2 rows. So I will get a 2 by 2. When I go to the 3 by 3, last 3 columns, last 3 rows. So, correct? So when I go to the chessboard, right, with this idea, this function idea, I am going to the chessboard now, right? So rough diagram. Look proper. Okay, so when I go for the first 1 by 1, if I concentrate on only the top left corner of a square, it's a function. Because to count a square, it is enough I count the top left corner. Why? 1 to 1 function. So therefore I will be getting 7 into 7 how much? 14. I will be leaving this column. 1, 2, 3, 4, sorry. 8 into 8, made a mistake, right? 8 into 8, I will be leaving the 9th. Then when I go for the 2 by 2, I must be leaving this fellow cannot become the, because I need a 2 by 2. But this fellow will become. The same thing will happen for 2 rows. So what will I get? Then I will get 6. So I get a formula, 1 square plus 2 square up to 8 square. See, what I try to say is, of course, you can do by the other way. The functional idea is something amazing. There is a lot of things with the functional idea. So slowly you can develop that. But functional idea means your it's like every square has got only top left corner is a function. It's got only one image, one association. And the squares are the domain, points are the fellows in the codomain. correct? And the range will be these fellows. This fellow won't come because this dot will not come in even in the what? At the beginning, 1 by 1 also it won't come. What is range? Set of associated fellows. So I take these squares as codomain, then I take dots as codomain, squares as domain, dots as codomain, and the range fellow only the associated dots. So it is how you, imagine. It's not always doing with numbers, but this absolute value function definitely you can't do with images. Understand?